And did you know then going into your PhD and kind of through that time that you wanted to go into industry?
No, I did not. So not at all, in fact. And I didn't really know what industry was about. So I think trying to decide that you want to do that sometimes too early is maybe a decision that's not informed by any evidence. But all I knew was that I enjoyed this subject material and that I was good at it, and that an education in engineering and mathematics and sort of becoming a very strong thinker and versed in quantitative methods would open up opportunities. I didn't necessarily think I wanted to pursue industrial opportunities. In fact, I did a postdoc after my PhD thinking I may very well be involved in academia. And almost all of my thesis work was done at Argonne National Lab, by the way. My advisors were at Northwestern, but the project that I gravitated toward was a DOE project, with a really talented physicist, named Igor Aronson. He's a faculty at Penn State now, who was doing this really exciting work in non-equilibrium physics. So I got interested in that subject. I heard him give a talk on that subject. So I actually got a lot of government lab. Probably the last 2 years of my PhD were almost entirely at Argonne Lab. Mm-hmm. So, in the material science division there, being around some fantastic mathematical minds. A friend of mine, Dmitry Karpev, was there as well, phenomenal mathematician. And Igor Aronson was my advisor. So I think I answered the earlier question, hopefully. But yeah, I had no idea, probably until maybe a couple of years, even into my postdoc, that I was going to go into industry.
Mm-hmm. Can you talk about some of the experiences that you had outside of the classroom and just doing research, both at your undergrad institution and graduate level, that kind of led you to maybe make some of those decisions about where you wanted to go?
Yeah, that's a really important topic. And the truth is, almost all of the stuff I did outside of the classroom is really what led to my career path, right? So, undergrad research at Delaware, this was really a time where I was, when you're an undergrad student, you're learning a lot. I wasn't necessarily very well versed in mathematical methods, so I was learning a lot from Dr. Edwards about asymptotic techniques, and numerical methods. I never took any undergrad courses in asymptotics or numerics, I'm sure, as most people haven't, right? Or maybe there's small courses in numerics I might have took. The undergrad research experience was just learning new things and sort of understanding how good I was at it and how interested I was. Now, when it was obvious that I enjoyed it and that I was fairly good at it, research at Northwestern was a little bit different from a sort of a classic mathematical thesis. So, my advisor was a theoretical physicist, brilliant mathematician, but his research focus wasn't on numeric mathematical methods, right? So his goal was to understand physical systems, particularly systems that exhibit what they call self-assembly. Very interesting systems. Anything from things like bird flocking to elephant herds to, in my case, I was studying cellular self-assembly, systems in which there are underlying active processes. Okay, and spontaneously you'll see pattern formation or collective ordering in these systems. So you'll see bird flocks, maybe that look like a cloud of birds, and then all of a sudden you see them flocking together, right? Mm-hmm. Well, it's not clear that these birds are talking to each other, right? There's no evolutionary argument to say why this flock should have formed, and it turns out you can predict these formations without any of that. You don't need leaders, you don't need God, you don't need evolution. You need simple interactions in a system with, and basically noise, and it's remarkable what you'll find. And so I was studying how this happens in the cell, essentially how filaments called microtubules that are constantly polymerizing and depolymerizing dimers interact with proteins to form structures. And it turns out you can predict that formation, without leaders or tubules talking to each other, right? Wow. Or evolution by, writing down the underlying physics that governs these active equations and solving those equations. So when for us, he was interested in predicting those formations, and we would use any mathematical techniques at our disposal to figure out that problem. Mm-hmm. Unbelievable experience. Super, super smart guy. We got, we did some great research. We got papers out of our work. And, I really love those guys that I worked with too.